Welcome to Lesson 8 on the topic Future Perspectives and Innovation in Organic Farming. Today we will talk about how the organic sector is evolving and how new tools, policies, and research are shaping its future. We will focus on four main areas: technological innovation, case studies that show how these innovations are applied in practice, organic breeding techniques for resilient crops, and finally, the role of policies and research in supporting these changes. The idea is to understand not only the challenges, but also the opportunities that make organic farming a key player in building more sustainable and resilient food systems. Today, we start with one of the most exciting perspectives for the future of organic farming: technological innovation. For a long time, organic farming has been as more traditional, relying mostly on ecological knowledge and manual work. But now, new technologies that were first developed for conventional farming, like sensor, drones, artificial intelligence, and big data, are being adopted to fit the principles of organic systems. So let's look at some examples. IoT sensor in the soil can measure moisture, temperature, and pH in real time. So with this information, farmers can use a smart irrigation system that gives the right amount of water at the right time, saving resources and protecting the soils. Drones with special cameras can fly over the fields and detect early signs of disease, pests, or nutrient stress before the human eye can see them. This allows organic farmers to react quickly and prevent problems without relying on synthetic chemicals. Another important tool is decision support systems. These combine data from satellites, weather forecast, and the farm itself to help with crop planning, nutritional management, and even certification processes. And on the consumer side, blockchain, mobile apps makes food traceable from farm to the market. So with a simple QR code, people can check how and where the products was produced, increasing trust in the organic label. But of course, there are also barriers for all these. Many small farmers cannot afford drones and sensors. So some live in rural areas with poor internet or do not have enough digital skills to use these tools. So data privacy and the lack of connection between different platforms are also make things more difficult. This is why public support and training programs and also cooperation between farmers, researchers, and policymakers are so important. So these challenges are addressed. Digital tools can truly support organic farming. Now let's look at a real example of how technology is being used in organic farming: the Smart Future Organic Farm project in Apulia, Italy. So the project focuses on organic cereals production, especially durum wheat, which is very important for the region's agriculture and economy. So the main goal is to make farming more sustainable, innovative, and even carbon neutral, while at the same time giving farmers useful tools for better decisions. Two digital applications are at the center of the project. The first one is CWFP, so a software that calculates the carbon and water footprint of durum wheat. It considers both direct use, like irrigation or fertilizer, and indirect use, like energy for machines. So this gives farmers a clear picture of the real impact of their activities. The second tool is Decision Support System, or DSS. This system allows farmers to test different farming strategies and see how they might affect the environments over the long term. So, for example, it can compare the impacts of crop rotation, cover crops, or reduced tillage, showing farmers which practices are best for soil, water, and carbon balance. So, what makes this project special is where it makes place. It is being tested in Capitanata and Alta Morgia, two areas in Apulia with a strong tradition in durum wheat. By combining tradition and innovation, the project showed that even very old farming systems can adapt to modern sustainability challenges. These initiatives is supported by CREA, the Italian Council for Agricultural Research, together with universities, research centers and organic farms and the local organizations too. Importantly, it is fully aligned with European strategies like Green Deal, the Farm to Fork strategy, and Biodiversity 2030. Another point that I want to focus on is the organic breeding techniques. Organic breeding is about developing plant varieties that can perform well in organic system, where there are no synthetic fertilizer or pesticides to rely on. This is very different from conventional breeding, which often focus on uniform crops and responsiveness to chemical inputs. So, what are the main goals of organic breeding? First, nutrient use efficiency. Crops need to make the most of natural soil fertility, compost, and organic matter. Second, tolerance to stress, like drought, heat, salinity, or poor soils, which are becoming more often and more common with climate change. Third, resistant to pests and disease without the use of synthetic chemicals. Then, with the competitiveness, meaning that plants are grown strong, cover the ground, and naturally reduce weed pressure. And finally, the compatibility with beneficial soil microorganisms such as mycorrhizae and nitrogen-fixing bacteria, which help recycle nutrients and keep soils alive. A very important point is the method. In organic breeding, varieties are often selected directly in organic fields. This is called in situ selection. These ensure that plants are tested and adapted under real organic conditions. Another method is the participatory plant breeding, where farmers, researchers, and seed companies work together. In this way, varieties are co-created, meeting both ecological and local needs. EU policy is also supporting this shift. Regulation in 2018, the number 848, now allows the use of organic heterogeneous material. So seeds that are not uniform but diverse and therefore better adapted to organic conditions. At the same time, new EU seed law reforms are discussing how to officially recognize organic breeding as a distinct field within the seed sector. Today, techniques like genome editing with CRISPR are not allowed in EU organic farming. So some scientists think these tools could help if they don't add for DNA, but for now, organic rules stay strict and GMO free. So the key point is that organic breeding is very important for the future. With climate change and unstable markets, we need crops that are strong, diverse, and well adapted to local conditions. This can only be achieved if farmers, researchers, and policymakers work together to create seeds that ensure both food security and sustainability. We talked about technological innovation and organic breeding techniques. Now let's move on the role of policies and research in supporting these changes. Policy is one of the strongest drivers of organic farming in Europe. With the European Green Deal, the EU has set a very ambitious goal. By 2030, at least 25% of all farmland should be organic. This is not only about consumer choice, it is about making farming a central tool for sustainability. The Common Agricultural Policy 2023 to 2027 play a big role here. It is now includes eco scheme, which give farmers extra payments when they adopt practices that protect biodiversity and improve soil health or reduce greenhouse gas emissions. This means that organic farmers are rewarded not only for producing food but also for delivering ecosystem services. But organic farming is also part of other big EU strategies. The Biodiversity Strategy 2030 calls for at least 10% of farmland to be managed as high nature value areas with